Hello, everybody. Great to see you. Today, I am recording this on Thursday night for Friday. Um, and looking at the weather situation that's happening, it's supposed to snow 3 to 6 inches tonight. Like, what? So by the time you're watching this video, there very well could be a whole bunch of snow on the ground outside, which is not okay. You know, it's like halfway through April. It should not be snowing that much at this time of the year. Like, it should be warm. You know, we're past spring break. We should be able to be going outside, especially since we've been quarantined and everything. We should be able to be enjoying the outside more, you know, and it's just kind of a bummer. You know, we're getting this much snow. Hopefully it only stays for like a day or two and then it's all gone. Hopefully it'll warm up, which I think it's supposed to start warming up, so hopefully it does. Just so you guys know, as far as the direction of algebra, so we've got 2 chapters left in the book, and I think we only have like 15 actual school days left. I think so. There's really 2 things I could do. I could try and really just push through both chapters as fast as we possibly can to get through both of them. But I really don't think that's going to be very fair to you guys, especially since things are so difficult already with not being able to meet in person. So I think what I'm going to do is I'm just going to slow things down quite a bit. I'm just going to really focus on this chapter, and we probably won't even get to chapter 12 at all, which is kind of a bummer because chapter 12 is pretty awesome. Chapter 12 is all about like probability and some statistics stuff. In fact, the end of the school year, I've been doing this huge event between all of my classes. So Math 8 finishes with probability also. So basically, it's like this. It was supposed to be like this combined big thing, which I did last year. I did it, you know, a different school that I used to teach at as well, and it was awesome. Like, the kids loved it. It's a zombie survival simulation that has to do. It's like a big game that involves probability and stuff like that. And basically, you're trying to survive the zombie apocalypse. So it's this event that you know, spans a couple of days, basically like 2 or 3 days in my class. You got to go out and like find hidden clues out in the hallway and in the school, and hidden artifacts and items that give you bonuses towards surviving and things like that. It's actually a lot of fun. I'm really pretty bummed that you guys don't get to participate in it, just because we won't be able to meet in person to do it. It's kind of a bummer. I was looking forward to doing it, but unfortunately we won't be able to get to do it. So that's probably one of the biggest bummers for me is about this whole closing thing, is not be able to do that with you guys, because I know you guys would have liked it a lot. But I do want to let you know we are probably just going to finish with chapter 11. We might get to a little bit of chapter 12 if we have time, but we're going to probably slow down quite a bit, not cover nearly as much every day, and kind of just really make sure that we understand chapter 11 instead of rushing through 11 and 12 before the end of this year, because I don't think that would be very beneficial to you guys. So let's go ahead and get started. We are on lesson 2 of chapter 11. So our objective for this lesson is to be able to multiply and divide rational expressions, and then to simplify complex fractions. Okay. So many problems, again, I would still recommend you guys keeping notes and all that stuff, because you can use them on the tests and quizzes. Many problems require finding products and quotients of rational expressions. You can multiply and divide rational expressions using the same properties you use to multiply and divide numerical fractions. If A, B, C, and D represent polynomials, then A over B times C over D, you just multiply straight across. You get AC over BD. Okay, so our first couple of examples here says multiplying rational expressions. What is the product? State any excluded values. We're just going to multiply straight across. Okay, so first we do 6 times negative 2, which is negative 12. And then a squared times a to the third. You guys remember what you do when you're multiplying powers with the same base? You add the exponents, right? So they both have a base of a. So you're multiplying. When a squared times a to the third is a to the 5th power. Sorry, that is not a 9 to the 5th power. Even though it might look like it, it's an a to the 5th power. Okay. Part B, again, we're going to multiply these straight across. Okay, so the product, okay, we're actually just going to keep these as, oh, by the way, I forgot. It says state any excluded values. What can a not be equal to here? Okay, well, remember, a, or the bottom of a denominator, can't be equal to 0, right? So here, the excluded value, a, cannot be equal to 0. Okay, so that's the excluded value. For B, we're just going to multiply these across. I'm not even combine these. I'm just going to state the product. So our products is going to be x minus 7 times x minus 5 over x times x plus 3. Okay, I'm just going to leave it like that. I'm not even going to multiply them or FOIL them out or anything like that. Okay, that's our product. Our excluded values then, again, we want to look at the bottom here. What can x not be equal to, right? So x can't be equal to 0, right? Because 0 times x plus 3 is 0. You can't have 0 on the denominator. Okay, what about this? What can x not be equal to here equal? Or, oh, wow, I just messed up my words. What can x not be equal to here so that would be equal to 0? Well, if x is negative 3, okay, negative 3 plus 3 is 0, and then 0 times x is 0, so x can't be 0 or negative 3 here. Both of those are excluded values. Okay. All right, I want you to go ahead and do this on your own. Okay, go ahead and pause the video. See if you can find the product here. For part B, you don't need to necessarily FOIL it out or anything like that. Just show the product. Show them being multiplied. All right, so hopefully you did that. First, 5 times 3 is 15 over y times y cubed. Okay, this is like y to the 1st times y to the 3rd, so that gets us y to the 4th power. And then for B, we're going to have x times x plus 1 on top. Gosh, I always forget the excluded values. Okay, y can't be equal to 0 for that one. Okay, so on this one, x times x plus 1. Here we've got x minus 2 times x minus 3. I mean, if you wanted to FOIL these out and combine them, you could. Okay, but to find the excluded values, it's easier just to keep them separate, right? So on the excluded values, x cannot be equal to 2 or 3. Okay, because 2 minus 2 is 0. 0 times x minus 3 is 0. And then 3 minus 3 is 0 times x minus 2 is also 0. All right, problem 2, using factoring. So as problem 1 indicates, products of rational expressions may have excluded values. For the rest of this chapter, it is not necessarily to state excluded values unless you're asked. Whew, that's a relief because I felt like I was constantly forgetting to state the excluded values. You only need to state them now if it asks for it. Okay, so that's kind of nice. All right, so sometimes the product AC over BD of two rational expressions may not be in simplified form. You may need to divide out common factors. So we've got this multiplication right here. It says, what's the product? Well, first, to find the product, it might be easier for us to factor these first. X plus 5 can't be factored, but 7x minus 21, we can pull out a GCF. So I'm going to rewrite this x plus 5 on top. That's already good. I'm going to pull out a GCF here to 7. If I pull out a 7, I get x minus 3 then in parentheses. Okay, on top on the left side, 14x is already factored, right? I can't really pull out a GCF there. So that's just 14x. On the bottom, x squared plus 3x minus 10. Let's see if we can factor this. So I need factors of negative 10 that add to positive 3. Okay, well, that would be, so factors of negative 10 that add to positive 3, that would be negative 3, no. Sorry, not negative 3. Well, let me think here. Sorry, negative 2 and positive 5, right? So x minus 2 times x plus 5. I think that's right. All right, so negative 2 times 5 is negative 10. And we got negative 2x, positive 5x. Yeah, okay, we're good. All right. Now, if you think about this, x plus 5 times 14x is going to be on the top. 7 times x minus 3 times x minus 2 times x plus 5 is going to be on the bottom. Can we simplify things before we multiply though? Here we've got an x plus 5 and an x plus 5. Those can be canceled out right away. Here we've got a 7 and 14. Those can be canceled to 2 over 1. Now that we're simplified, on top, now all we have left is 2x on top. On the bottom we have x minus 3, and then we have x minus 2. This is our simplified form then of the product. Okay. So using that method, I want you to go ahead and try this. Got it? Then on your own, I want you to see what you can factor out first. Okay, and then use that simplified product, simplify things, and then find the product. Go ahead and pause the video and do that now. All right, so hopefully you took time to do that. Let's go ahead and simplify first. So on top here we have 3x squared, and on the bottom we've got an x. We can actually already cancel these out. So x squared divided by x is just going to be x on top, and on the bottom here we're just going to have 1 remaining, right? X squared divided by x just leaves x, or just leaves 1, right, on the bottom, and then x to the first on top. The top then we're going to factor. Okay, what can x squared plus 3x plus 2 factor to? Well, that's x plus 2 times x plus 1. Okay, now our x plus 2's can cancel out on top and bottom, and then we've got 3x times x plus 1 on top, and on the bottom we have 1, which actually we don't even need to do, so our fraction basically just goes away and we just have this 3x times x plus 1. Okay. All right. Part 2, or part B. In problem 2, suppose you multiply the numerators and the denominators before you factor. So let's say you didn't simplify, you didn't factor first. Will you get the same product? The answer is yes. I mean, you can multiply first and then simplify. It's totally fine. It doesn't matter which order you do them in. You're still going to get the same answer. Okay. All right, problem 3 then. Multiplying a rational expression by a polynomial. You can also multiply a rational expression by a polynomial. Leave the product in factored form. Okay, so first, we've got 2m plus 5 over 3m minus 6. And then we've got that times this polynomial. Okay, well, what we want to do is we want to factor m squared plus m minus 6. So what factors of negative 6 add to positive 1? Well, we know that positive 3 and negative 2 multiply to negative 6, and they add to positive 1. So I'm going to rewrite this here. 2m plus 5 over 3m minus 6. And then I'm going to switch this to m, let's see, I said it was m plus 3 times m minus 2. All right, 3 times 2, that's negative 6, and then 3m plus negative 2m is a positive m. Okay. All right, so now we've got a, oh, actually, the 3m minus 6 on the bottom. I can actually pull a GCF out of that, right? I can pull a 3 out, right? So this becomes 3 times m minus 2. Right, if I pull out the GCF. Okay, well now this is basically like over 1, right? So now I can cancel out my m minus 2's. So basically now all I'm doing is 2m plus 5 times m plus 3. So 2m plus 5 is left times m plus 3 over the 3 times the 1, which is 3. So our simplified product then is 2m plus 5 times m plus 3 over 3. Okay. All right, go ahead and try it on your own. Pause the video, and then I'll come back and I'll answer I'll help you through these there once you're done. All right. So first, let's look at some GCFs that we can pull out of these first parts right here. So 2x minus 14. Can pull out a 2, so it becomes 2 times x minus 7. On the bottom, 4x minus 6, I can pull out a 2 again. So 2 times x, 2 times 2x minus 3. Well, what's nice is I can actually cancel out those 2's right away. Okay, now let's factor the 6x squared minus 13x plus 6. Now remember, since we have an a here that's other than 1, I want to multiply 6 times 6 first. So that's 36. So I need factors of 36 that add to negative 13. So let's think of our factors of 36. We have 9 and 4, right? Or actually, negative 9 and negative 4 should work, right? Because negative 9 plus negative 4 is negative 13. So what we're going to do is we're going to actually split this up. Now remember, when you have an a here other than 1, like if it's not just x squared, we can't just do, x minus 9 times x minus 4. Now we actually have to split this middle term up into negative 9x minus 4x. That's when we so it kind of changes a little bit. So this is going to be 6x squared minus 9x plus negative 4x plus 6. Okay, let me just cross this out so we don't get confused. Now I group together the first two and I group together the last two. Now I want to factor out a GCF of each. Okay, so, and just to make sure we're not running into this part right down here, I'm going to move it up here. So what can I pull out of a 6x squared minus 9x? Well, I can pull out a 3x, right? So it becomes 3x times, so I've got an x left. No, sorry. Let me erase that. So if I pull out a 3x from the 6x squared, I get 2x left on the inside, minus 3. Okay, now the negative 4x plus 6, I can pull out a negative 2, and then I'm left with positive 2x minus 3. So I've got 2x plus 3 here and 2x plus 3 here. That's what we want. So my factors then are 3x minus 2 times 2x minus 3. Okay, our 2x minus 3's can then cancel out, since this is basically a fraction, right, over 1. So now I have this canceled out, and basically this is over 1. So I'm not going to have anything now on the bottom. So basically it's just going to be whatever's left on top. So x minus 7 times 3x minus 2 is going to be our simplified product. Okay. All right, that was kind of a tough one. Let me erase. Okay, and let's look at B now. Okay, so let's factor the top part here. X squared plus 2x plus 1. Well, that can factor to x plus 1 times x plus 1, right? It's x plus 1 squared. Okay. On the bottom, hopefully you were able to figure out what this is. Remember, this is a difference of two perfect squares. So this is x plus 1 times x minus 1, right? Remember, we've got a perfect square here and a perfect square here, and they're separated by the minus sign. That's x plus 1 times x minus 1. So we can actually cancel out an x plus 1 on top and bottom here. Now, x squared plus 2x minus 3. Factors of negative 3 that add to positive 2. Okay, that is x plus 3 times x minus 1. So now our x minus 1s can cancel out. Okay, and this is over 1, right? So now I have nothing left on the bottom, so now all I have left are x plus 1 times x plus 3. That's our simplified product. Okay? And that's it for today. So like I said, we're going to kind of go through this chapter a little bit slower than we were planning on it. So we're just doing these first 3 problems today. We're going to finish this lesson on Monday. There's no homework assignment for today. Basically, one thing I do want to remind you of, though, is that starting today, every Friday, I'm going to have host a Canvas Q&A session with you guys. So I'm going to invite everybody in both sections of algebra at 1 o'clock. I'll be available here at my computer to answer any questions that you might have. If you have questions over Wednesday's assignment, you can feel free to come in and ask me questions. Remember, Wednesdays, so basically you have 2 days to work on these assignments. So basically, Wednesday's assignment isn't late yet if you're still working on it today. So if you have questions on it, you can feel free to come by and ask questions on that. Even if you don't have a specific question, if you just want to come by and listen to some questions that other people are asking, so that if that might be beneficial to you, you can do that also. You can come for 2 minutes, you can come for 10 minutes, you can come for the whole thing if you want. Or if you just want to come by and say hello to me, that's totally fine also. It's totally up to you how you use it. So that's starting at 1 p.m. today. Hopefully you're watching this video before 1 p.m. so that you can get this reminder. If you're watching this after 1 p.m., then you're kind of out of luck. You'll have to wait till next week. But yeah, today at 1 p.m., I will be sending out the invitation. So if you want to join me for that, you can, in case you need it. So, all right, that's it for today. I hope you guys have a fantastic weekend. I may see you here today at 1 p.m., but if I don't, then I'll see you guys later. Bye.